If you have more than one single condition in your vessel, chambers are needed. It can be internal pressure or temperature, external conditions, or even a different fluid. Let's see how you can create and handle chambers in this new chapter. To create a new vessel, we go to the menu File, New, we select pressure vessel, and then we say OK. We already see in the templates a lot of vessels with numbers 1 and 2 designing multi-chamber vessels. But to understand them completely, we will start with one chamber vessel. Then we click on Next. Since we are not running calculation for this model, you can have any design code or standard of your choice. Just have your settings ready and then click Next. Let's set up some conditions. I'm going to put pressure, design temperature, liquid level, and then, as I like to do for this exercise, insulation. I'm going to input 2000 millimeters. Then click on Next. Again, we are not running calculation, so no special setting for this. Item. And then here I will just go with the default values. Say Next, Next, and since everything is okay, it's Next. Now I have the model of my vessel. I will divide this shell in 3 equal parts. I will click on the shell, then right-click, Split Shell. Also, I can select it from the list of components, then go to the menu Edit, and Split Shell for the ones that prefer. Then instead of 9 meters, I'm going to divide it in 3 parts of 3 meters. Then I press OK. I'm going to add an intermediate head in both divisions. So I will set for the first shell, then right-click, insert a copy after selection. And I'm choosing an elliptical head. Then I'll just press OK. See that my insulation now goes from one reference line to this reference line. So now I have 2. You can see that there's a 1 here and 2 here referring to the first and second chamber. I will double click on the background to go to the general properties, and in the same condition tab, I can see that now I have a second chamber. I will fill properties for this one too. 0.8 megapascals, 120 centigrades. Then here I'm going to input 2500, and again an insulation thickness just inferior to the one I input before, so 100 this time. I will say OK. Right, now I will do the same with my second shell. I will right-click, insert a copy after selection, and then instead of a shell, I select elliptical head and just press OK. Now I effectively have 3 chambers. I have 3 reference lines. Also, when I click on the background, I have my 3 chambers activated. Also, I recommend seeing the chamber number in the list of components. My recommendation is to always set the geometry after the designation and the chamber number after the geometry. Those are the useful informations from the list of components. You can see that all the elements are assigned to a chamber number. That chamber number can also be seen by clicking on any element, and at the top right corner, you will see the chamber number. This is the most intuitive meaning of chambers in AutoPipe vessel, meaning imposing a physical barrier such as an intermediate head between 2 sections to create 2 closed volumes. In the second part of the video, we will be pushing these limits. Before that, I would like to show you how nozzles are impacted. We go to the menu Insert, Nozzle, then we will input a tag, an abdominal diameter, and then allocation, 2 meters. See that when I quit that field, my parents gets updated. This is the tag of the element on which this nozzle is located. The chamber number of that nozzle corresponds to that of the parent. You shall use this as indications and not change it here unless you are in a jacketed vessel, as you can see in another video. Then we set an orientation of 0. We go through the material tab, we apply the default data, and then we say OK. You can see here that my nozzle has been created. As promised before, let's explore the second option of creating chambers. Meaning we are going to double click on the second chamber and we are going to uncheck the pressure bearing option. Then press OK. Now you can see how installation of the second chamber has moved from the intermediate section to the upper one. I only have 2 reference lines. The third one has disappeared. And here in the list of components, this element, the one I set as non-pressure bearing, now appears as P equals 0 in the geometry column. In fact, if I double click on the properties, you can see that the third chamber column is disabled. This is because by setting it as non-pressure bearing, this part is not subject to internal nor external pressure. We will only perform structural shells, so the thickness will be checked under the external loads, but there will be no design pressure code check. To see it more clearer, we can double click on this head, change this orientation. So now you can see it's like we had 2 vessels with an intermediate skirt. In fact, the non-pressure bearment itself is enough to divide a vessel into chambers. We can see that by deleting both intermediate heads. You can see that both reference lines remain and the insulation too. This non-pressure bearing element can be as small as we need it to not interfere with calculations. When this is useful? Well, one example is already on the screen when you have 2 different insulation thickness, but also when you have different conditions, difference in temperature, difference in pressure. So in auto-by-vessel, chambers are not to be understood as physical enclosed volumes, but as a group of consecutive elements, because they must be next to each other, with the same working conditions. Conditions in the broad sense, as they not only refer to pressure and temperature, but also insulation thickness or corrosion thickness, among others. This is the key to understand jacketed vessels that we will explain in the second part of the multi-chamber vessel series. Thanks very much for watching.